Okay, hi guys. Um, so today we'll be doing um, Leetcode problem called cherry pickup. So we're given an n power n multiplied by n grid representing a field of cherries. So each cell is one of three possible integers. 0 means the cell is empty, 1 means the cell contains the cherries that we can pick up, and -1 means the cell contains a thorn that blocks our way, right? So we want to return the maximum number of cherries by doing the following actions. Okay, so starting at the position 0, 0 and reaching n-1 by moving right or down to valid path cells, means cell with 0 or 1. After reaching n-1, we return back to 0, 0 by moving left or up to valid path cells. Okay, so if there's no valid path between 0, 0 and n-1, then we return 0. Okay, so basically we really need, what do we need to do here is that we need to actually have the intuition to solve the problem. So in order to solve this problem specifically, then okay, so there are two phases here, right? So we want to move from this cell to this cell, and then from this cell back to this cell. Okay, so how about doing each of these individually, right? So what I mean by that, I'm going to starting from this cell, I'm going to reach this cell, and then I want to be greedy and I want to take the maximum number of cherries possible, right? After doing that, each time I pick a cherry, I turn it into 0, and then basically I do a phase 2 for the problem where I'm going to pick up the maximum number of cherries by moving from the bottom right cell to the top left cell, and then pick up the maximum number of cherries possible, and then I add them up, right? But is that enough, right? Okay, so the first intuition is that we are going to do it in two phases. Each phase we are going to take the maximum number of cherries and then add them up, right? Okay, so how can we do that? Basically, if you're familiar with this type of question, is actually going to use a dynamic programming, right? Okay, so for example, for a cell, if we are at this cell, then the only two options that can lead to the state of us being in this cell is that one is that we're going from the cell up above us, or we are moving from the cell that's on the left of us, right? Okay, so let's call dPRC is going to be the maximum of dPr-1 C or dPRC-1, and then if in the current cell there's nothing there, then basically we don't add anything to the previous dP, or if this cell contains a cherries, right? Okay, then we need to add the value in this cell into the previous dP. Okay, so we are going to do that for every cells, and then we are going to return the dP as at the bottom right cell, right? Okay, so let's do it. First, I'm going to initiate our dP array. But in this problem, I'm going to use a map. Okay, so first I'm going to set the value for the dp at this position is going to be equal to whatever the value here, right? Okay, so if you look at the constraint, then grid 0 0 or grid -1 is always going to be not a turn, right? So we can set it into the dp at position 0 0 by the value at grid 0 0. Okay, so now I'm going to iterate from left to right, and then from a row by row, right? Okay, by doing row by row and then from left to right, I'm going to ensure that each time I'm going to compute the value for a cell, right, I'm going to have the requirement dp to compute it, right? So I'm going here, these two cells is outbound. I'm going here, okay, I have the information for the one that's on the left of it, basically the same here, and then I'm going here, I have the information for the cell above us. I'm going here, I have the information for this cell and this cell, right? So we need to do it in the correct order. So dp, since we're setting the value for dp 0 0 already, I'm just going to ignore if r plus e is not equal to 0, right? And also grid rc is not -1. It's going to be equal to max dp r -1 c plus grid rc dp rc -1 plus grid rc, right? Okay, so after doing all of this, I'm going to return dp at n-1 n-1. Field objects not subscriptable. Okay, so as you can see here, it's return 4, right? So as you can see here, in one pass, the most number of cherry that we can pick up is actually 4 by doing the following action, going down, down, right, right, right. Okay, so now after we doing that, we are going to mark all of these cells into 0, and then we do another pass. And in this example, if we do it in a greedy way like that, it's going to return 5, right? Because in the second phase, I'm going to take this cell and then I'm going to just move all the way to n-1. No, I'm going to move from this cell, pick up this cell and then move back to 0, right? But let's take a look at this example. Here we have cherries like this, right? Okay, so the first path we are going to take the maximum number of cherry, then we can take 7 of these, and then in the second pass we can take basically 2 of these is marked 0. Second pass 2 2 2 2 2 2 2. Okay. Okay, so if we do it in a greedy way, then in the first pass we are going to take the most number of cherries, right? And then we take this, and this, right? And by doing that, we can collect 6 cherries, right? In the second pass, we are going to either take this or take this, and that's going to be 7 in total. However, if you look carefully, it's actually possible to get all of these 8 cherries on the board, right? By doing this, and then in the second pass we are going to do this, then we take all of the cherries, right? So now it's safe to conclude that we cannot do 2 phases DP individually and add the result up, because there's the counter example above. Okay, that's the first observation. As the second, actually, the first is that we can actually use to solve a simplified version of the problem. Okay, so what is another observation is that if you take a look carefully, here we can basically, after reaching n-1, n-1, we can reach back to 0 0 by moving left or up. Okay, so let's take a look. If we are at here and then we move up in a path like this, is this the same as moving from 0 to n-1 with the same path? It is actually the same, right? Okay, so moving from n-1 to 0 is the same as moving from 0 to n-1, n-1. Okay, so that's another observation. We know that we can use some type of DP to solve this problem, but we cannot do it in 2 phases individually, right? So how can we do it? We can imagine as 2 people, right, running simultaneously and then pick up the cherries, right? 2 people are starting from this position and then they are going to reach this position in time t, right? Okay, so we need to solve for dpr, solve for dpr1 c1 r2 c2, r1 plus c1 is going to be n-1. Return the answer. Okay, right? So basically we have 2 people on this board that's going to travel in the same speed, and then they are going to pick up cherries, and then they're going to reach the final cell n-1 in time t, right? And then we need to return the dp at that state. Okay, so how can we do it, right? For this state, then basically it's just the same as this, right? For dp c1 r2 c2 is going to be the maximum of what? dp r1 c1 minus 1 c1 r2 minus 1 c2 dp r1 minus 1 c1 r2 c2 minus 1, and vice versa. There's going to be a total of 4 options. It's just going to copy paste it. Then another option here. Okay, that's another observation. We can solve for dp r1 c1 r2 c2 in this type of way, right? But now we need to going to add what? Okay, so for example, if r1 c1 and r2 c2 is not in the same cell, right? We going to do grid r1 c1 plus grid r2 c2, because this guy is going to take the cherry at r1 c1 and this guy is going to take whatever it is in r2 c2. But if r1 is equal to r2 and c1 is going to r1 is going to be equal to r2, it means that these two guys are in the same cell, and then we only need to add whatever the value in this cell one time, right? We have to deal with cases where r1 is equal to r2, since we going to double count the cherry. That's another observation. So another observation is that r1 grid r1 c1 and grid r2 c2. Else they are going to go into a cell that is blocked by a thorn, and it is not a valid state, right? Okay, so another observation is that you can counter this solution by saying that what if the first person is going to take this cherry, and then the second person is going to reach this cell later, but we cannot check the cherry that we have picked up, and then we are going to double count it, right? Okay, so now here's a catch. In this problem, then for each state, then we are going to assume that these two guys travel on the same speed. So in order for a guy to travel from let's say x1 y1 into x2 y2, is going to take them a time called t, and then this t is going to be x2 minus x1 plus y2 minus y1, right? Okay, so since these two guys, in order for them to reach a cell, right, x2 y2, they're going to have to traverse in t time. Okay, so let's say that each time they visit a new cell, then a time passed by 1. Okay, so by the time they reach this cell, it's going to take them whatever this is, seconds. Okay, so since they are traveling at the same speed, in order for a guy to reach a cell sooner than another guy, right? Than the second guys. It is not possible, right? They are moving at the same speed. If they are going to visit the same cell, they are going to visit it at the same times. And if that's the case, then whatever that we are doing here is going to cover it, right? We are going to make sure that in cases where R1 is going to be equal to R2, then we are not going to double count the cherry, right? Okay. Take time to think about it, right? Take time to think about it. This is a hard problem. It's okay if you cannot solve it or don't have the intuition for it. After that, we can just return whatever at the dp r minus n minus 1 and minus 1 right? And that's basically it. For this problem, it's going to be a 40 dp. Right? So you can basically know the time complexity is going to be n to the power of n quadratic, right? Space complexity basically the same. Okay, so let's code it up. dp 00 is going to be equal to the grid 00 for R1 in range n, for R2 in range C2 in range n. If R plus C is not equal to 0, and R plus C is equal to R1, R2 plus C2, means that they are going to travel at the same speed, so R plus C is always going to be equal to R2 plus C2. Every other state is not going to be valid, and then grid RC is not equal to -1, and then the same for the other guy. Okay. Okay, that's it. And then since these two guys can be equal, right? They can be on the same cell. We don't want to overcount the additional cherry. So let's say that so if R is not equal to R2 or C is not equal to C, oh no, this is enough, right? If R is not equal to R2, then we can simply assume that they are on the different cell. Then we can count this one in, right? dp RC R2 C2 is going to be maximum of the fourth state that we are stating here, right? minus twist. Minus 1 C R2. Okay. Same here. Okay. Last but not least, remember to return the value at this state. I mean the state where these two persons are going to meet each other at the bottom right cell, right? If let's run it. Okay, so as you can see, it passed the two test cases here, but the constraint here is actually the n is 15, right? So 15 to the power of 4 is actually going to be 15 to the power of 4 going to be here, right? So it is possible that it's not going to pass all of the test cases, right? So let's submit it. Yeah, as you can see, it's failing on the test case 58. So is there a possibility that we can reduce the time complexity and the space complexity to something that's lower than n to the power of 4? And the answer is actually yes. So here, since r plus c is always going to be equal to r2 plus c2, why the need to iterate through all of the value of c2, right? We are always going to know that c2 is going to be r plus c minus r2, right? And then I'm going to untap this guy. Here, right? So we only need to check if this is not needed. C2 is inbound, right? Let's try this test case. Okay, so let's submit it. So the time complexity is actually going to be n to the power of 3. And then space complexity, since we are going to push in our DP hash map, n to the power of 3 state is going to be n to the power of 3 also. Okay, so that's it for today. So I hope that you guys understand the solution. This is a pretty tough problem. You can skim through the discussions tab. Okay, did anything why a simple BFS question is rated hard and later realize things is real hard? Because people misconcept it, and then they are going to naively doing a two phases DP and then just greedy take the maximum number of cherries on each phases and then add them up, right? And that's not going to be sufficient, because we have to imagine this problem as two people simultaneously moving at the same rate and then picking up cherries, right? Okay, so here If somebody asks this in interview, leave the car immediately and run far from this life. What the heck is this problem? This has to be one of the hardest problem on Leetcode. Okay, so this problem is actually hard, and I myself cannot actually. Initially, I cannot find a solution to solve it. I can only think of two faces, DP, as all these guys in the comment section. But after that, then after trying all of these solutions, I came to a conclude that we are still going to use DP. But since the constraint is small, so maybe we can try something much larger than just n to the power of 2. So n to the power of 4 is actually a little bit high, but after doing n to the power of 4, then okay, so here is a minor adjustment that can actually reduce the time complexity from n to the power of 4 to n to the power of 3. And okay, so I'm going in the right direction, right? So this example is actually one of the example in the discussion tab, and this helped me a lot, right? It helped me to realize that a two-phase DP is not going to be enough, right? A greedy approach is not going to be enough, right? We need to think of it like a 4D DP and solve all of the possible state of two people running at the same rate, right? And then when they reach a time t, what are the possible state and what are the maximum number of cherry they pick up at all of these states, right? After solving all of these subproblems, we can find the final answer for the final state that we need to return. Okay, so that's it for today, and I hope you guys understand the solution, and thank you for watching. See you guys in next video.